Hey there. I just want to give you guys some help with using imaginary numbers. That whole idea of how do we square root negatives, which up to this point has been something we thought we couldn't do. Remember that it's going to come down to somewhat just, or this is something you guys need to know, that when we want to take the square root of -1, we've defined that number as I, the imaginary unit. So I is equal to the square root of -1, and then in the same way that we talked about in class, that I squared is equal to -1. So these are things that you need to know in order to be able to do what we're doing today, and it will be taking advantage of these two facts. Again, they're essentially like definitions of what this, how do we do this. So if we want to do something simple like just reducing radicals, like we have been, so using that SOC method if we need to, really what it's going to come down to is that what's again called the product property of radicals, that the square root of -81 is the same thing as the square root of 81 times the square root of -1. We can just break this number, which is called the radicand, up into products. And so just that idea that if you take the -1 out of there, all of a sudden it becomes something that we know how to do. And so, of course, the square root of 81 is equal to 9, and then the square root of -1 is equal to I. So this is just 9 times I, which of course is just 9I. So the square root of -81 is equal to 9I. Remember when we write our I's, they usually have like a little tail on them, kind of look like backwards J's, so just so they are differentiated from ones. So then I look at the square root of -200. So again, the first thing I want to do is split that up into the square root of 200 times the square root of -1. And I always put the big number on the left, because in the end I know this part's going to become I, and the I on the right. When we take a number times a letter, our convention is to put the the letter behind it. So just kind of naturally setting it up that way. It doesn't matter which one you actually have on the front or anything like that. But 9 times I could also be stated as I9. We just it's kind of the same thing. Like if I said 9 times X is X9. It's the same math. It's just it's not how we're used to it. We always put the letter after. So just kind of little things I'm doing here. So again, I know that the square root of -1 is I, so that's going to be there. And then with that 200, I need to break that down, right? Since I don't know what the square root of 200 is, so I'm going to use the SOC method here. So that's 2 times 100, which is, and then 100 is not prime, so 2 times 50. And 50 is not prime, so it's 2 times 25, and 25 is not prime, which is 5 times 5. So I want to look for any, buddies. They got to go outside. So I got a pair of 2s, and I've got a pair of 5s. And then any lonely guys are going to stay inside. So as I put this back together, I have this 2 and this 5. They're coming outside. Now the I is also coming. It's not right. The square root of -1 is I. It's not like the square root of I or anything. So it's outside of the radical now. And then so the only thing that's inside the radical is that 2, that leftover 2. And of course, just like before, all this stuff is just multiplying. And so we end up with 10 I radical 2. So it really isn't any different than when we square rooted positive numbers. The square root of 81 is 9. The square root of -81 is 9I. The square root of 200 is 10 radical 2. The square root of -200 is 10I radical 2. So it really should be pretty simple to square root negatives. If I say it's like, what's the square root of -49? Well, just think about what's the square root of 49. It's 7. So the square root of -49 is going to be 7I. What's the square root of -4? Well, the square root of 4 is 2, so the square root of -4 is 2I. Okay. So really don't treat them, or don't think that they're way different or going to cause you way more headache than the other square roots we were already doing. Let's look at another thing we can do with these. So here we're just simplifying some expressions, and these are really just simplifying the way we've always been simplifying, either combining like terms, distribution, things like that. So really essentially almost just pretend this is like 3 plus 5x minus 7 minus 2x. So just imagine these are x terms, and these are constant terms, and be able to combine these here since they're both constants. So 3 minus 7, of course 3 minus 7 is negative 4, and then if I said 5x minus negative 2x, 5x minus negative, there we go, minus negative 2x would be positive 7x, since those would turn into a plus sign. It's kind of the same way that 5i minus negative 2i, those are going to turn to pluses, and so we're going to get 7i, so positive 7i. That's it. There's our complex number here, a real part and imaginary part, minus another complex number with a real part and imaginary part. Gives us a new complex number with a real part and an imaginary part. So this whole thing is a complex number. It has a real part and an imaginary part. Again, the convention is to put the imaginary part second. There's no problem, no mathematical problem of writing it 7i minus 4. It's the same value, just our convention is always put the imaginary part second. Pretty similar idea here with d. It's just a distribution problem. So I'm going to take 3 times 7, here I get 21. And 3 times negative 2i, so 3 times negative 2 is negative 6. So I get negative 6i. And then 5i times 7, which would be 35, positive 35i. And then 5i times negative 2i, so of course 5 times negative 2 is negative 10. And just like x, like x times x is x squared, I times I is I squared. And so, what we have here is we finished doing, we look in the middle here, we have these two I terms. Those can be combined. And then we have this term here at the back end, oops, I should say I squared, that says I squared. Well, the thing is we can simplify I squared because we know what I squared is equal to. So usually what I do with this is I circle it, just to kind of key in on it. And I just kind of come over here and say, well, it's equal to negative 10 times, and I squared is equal to negative 1, so negative 10 times negative 1. So this is really equal to positive 10. And I do write that plus sign just to highlight that for myself. And so what I have here is this 21 and this positive 10, that I can combine those as well. So 21 plus 10 is 31. And then negative 6 plus 35, that's 35 minus 6, that's 29. So plus 29i. So never leave an I squared in an answer. They should always be reduced, simplified to negative ones. So adding or subtracting, you should end up with a complex number. Multiplying these, you should end up with a complex number. We're not going to do any division with imaginary numbers in this class. It is certainly something that's doable, just not something that we're going to talk about. But there's our simplified result. Last thing we're talking about here with these is solving these equations, which in the past we would not have been able to solve before. So just noticing the difference between these two equations, that we are going to approach them a little differently. This only has one type of x in it. One has x squareds in it, but that's all it has, whereas this one has x squareds and x's. So we are going to have to approach these problems differently. I can just solve this by square roots, or use SADMAP to get x by itself. Is right. My goal here, get x by itself. So using SADMAP, so I want to look for any subtraction, addition to do first. So let's subtract that 27 over to the other side. So I got 1/4 x squared equals negative 20. And then when I get rid of that 1/4, I'm not going to divide by 1/4. We talked about that the other day, like why that's not a great thing for our brains to do. Do something else that we can make more sense of instead, that we are going to multiply by the reciprocal of 1/4. So we're going to multiply by 4 over 1, or more simply, we're going to multiply by 4. That's enough to cancel the 1/4 out. So x squared equals negative 80. And then I want to square root both sides, get rid of that square. And so I get x is equal to, so both the positive version and the negative version of the square root of negative 80. So don't forget that we should have two answers here, and that's why there's two, is because of the positive version and the negative version. But what is the square root of negative 80? All right, so I want to bring that over, and I want to stock that out, just like we're doing on the first page. So square root of negative 80, that's the same thing as the square root of 80 times the square root of -1. I do need to sock out the 80, which is 2 times 40, which is 2 times 20. 20, there we go. Pen is struggling today. 20, and then which is 2 times 10, which is 2 times 5. So look for any pairs. Got a pair of 2s, another pair of 2s, and only 5. And then what about that square root of -1 up there? That's I. So x is going to be equal to, so one pair of 2s gives me 1 2 on the outside. Another pair of 2s gives me another 2 on the outside. So 2 and 2, so that's going to be 4. And then our I, and then our radical, and then our only 5. Oops. So I should have had the plus minus in there, so I'm going to just go ahead and write down the other version. So the other version would also be the negative version, so x equals negative 4I radical 5. That's the other possible answer. Two answers. So we are using our square root of -1 to be I there, right? So we're going to look at this other problem here. Oops. Get this all grouped up. Oh, that's not what's happened. Struggles. Of course, you guys see this already. So 3x squared plus 8x plus equals -12. So since we have the x squared and the x, we need to go at it this different way. So either by factoring or completing the square or the quadratic formula would be the ways to go here. And on any of those methods, we want one side to be 0. So when there's two types of x's in the problem, you usually want everything on one side, versus when there's just one type of the x, you try to get stuff to the other side. So just drastic difference in how we solve these problems because of that change. So adding 12 to both sides. 3x squared plus 8x plus 12 equals 0. Now, if I could factor this, I would probably prefer to factor it. I don't want to do completing the square here because that 3, in the way, especially with the 3 would interact with the 8. But if I check real quick if it's factorable, my a times my c is 3 times 12, which is 36. So I need factors of 36 that add to be 8. And there just aren't going to be any, so 1 and 36 and 2 and 18 and 3 and 12 and 4 and 9 and then 6 and 6. There's just no way to combine any of those to get 8. So it's not factorable. And again, I don't want to complete the square. So quadratic formula is the guy. Right? So A is 3, and B is 8, and C is 12. So setting up the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. A's go here, B's go here, and C goes there. So x equals, so I got negative 8 and 6. Negative 8 and 6 here. Plus or minus over 6. Of course, 8 squared is 64. Minus, maybe. So I got 1 minus sign, no other, so it's going to stay minus. And then 4 times 3 is 12. 12 times 12 is 144. So underneath that radical, so we got negative 8 plus or minus 6, and 64 minus 144 is negative 80. I did not plan this, but notice we actually had negative 80 up here, so we actually already know how negative 80 is going to reduce. It's equal to 4i radical 5. So I'm just going to do that work. So this is just going to turn into 4i radical 5. So I get negative 8 plus or minus 4I radical 5 all over 6. So last thing I'll do here is check to see if I can reduce this, right? Because I can't actually do this math here, add the real numbers and the imaginary numbers. I can say I want to do it or I want to subtract them, but I can't actually do it. So I want to see if I can reduce my fraction. And again, where we look here is this triangle of the normal numbers, and I'm not looking at the I or the radical 5. I'm looking at these and saying, okay, yeah, these all do have a 2 in them. So I want to take that 2 out of everything. Let's see what this is going to do to me. Group this real quick so I can move it. So yeah, I just want to take a 2 out of each of these things. Right? Divide everything by 2, reduce it by 2. So x equals, so negative 8 divided by 2 is negative 4, plus minus, and then 4I radical 5 divided by 2, so again, just look at this 4, divide that by 2, so that's 2I radical 5. And then, of course, 6 divided by 2 is 3. So there's our final solutions, right? There's 2 answers right here because of the plus minus. So you can call that your answers, or if you're going to really feel like it, you could say x equals negative 4 plus 2I radical 5 over 3, and x equals negative 4 minus 2I radical 5 over 3. All right. That is that. Hopefully that helped a little bit. Let me know if you need something.